Okay guys, let's get started on lesson 8. Lesson 8 is about finding x-intercepts of y equals ax minus h squared plus k, so our function in vertex form. And our second part will be using this to help us solve word problems. So as you know, when we have our function in factored form, x-intercepts are really easy to find. When we have our function in vertex form, the vertex is really easy to find. So what happens when we have our function in vertex form, but we need to find the x and y intercepts? So I'm going to go through that before we get to word problems. So as we know, if we want to find the y-intercept of something, what we need to do is set x equal to 0 and solve for y. Solve. Conversely, if we want to find the x-intercepts of something, we need to set y to 0 and solve for x. So I'm going to do 3 quick examples before we move on to the word problem. So here we go with A. So I'm going to start with the y-intercept, meaning I have to set x equal to 0 and solve for y. So this is really straightforward. That's pretty easy. Now let's try finding the y-intercept. X-intercept. So for the x-intercept, what we're going to do is we're going to set y equal to 0 and we're going to solve for x. So here we go. So one thing you might want to do at this stage is to expand the left-hand side. But what I'm going to suggest and enforce is that you do not expand the right-hand side. So what we're going to do instead is we're going to just use reverse BEDMAS to help us solve this. So by that I mean we're going to bring 8 to the other side. Then we're going to divide both sides by -2. Okay, and this is the really key step here. When I want to solve for x, what I want to do is I want to take the square root of both sides. But something completely crucial here is I really have to remember to take both the plus and minus values of the square root of 4. So I'm going to write that as plus minus 2 equals x minus 3. And if I isolate x in this equation, what I'm going to get is that x equals 3 plus minus 2. Well, what does that mean? Well, what that means is that there are actually 2 x-intercepts. Okay, so the first one is going to be, when I add 2. And my second x-intercept is when I take the subtraction of 2. So actually, I have 2 x-intercepts. And if I were to go back and look at the graph that's given, okay, I could actually graph this to see if these two things jive. Okay, so we can see that our x and y intercepts make sense. Okay, so we're going to continue doing this 2 more times with 2 slightly different examples, but these examples are important to go through because they're different in important ways. So again, let's try solving for the y-intercept. And let's do the x-intercept. Okay, so in this example, I wanted to show you that the numbers don't always necessarily end up looking really nice. Okay, and that's the beauty of this way of doing it versus if I were trying to factor this, because I could not factor or think about 2 plus root 5 as being a factor of this quadratic. So if I ever need to find the x-intercepts, I just set to 0, y to 0, and I follow this procedure. So let's do one more. Again, another important example here. And what we should notice at this stage is that, isn't this impossible? Well, yes, it's impossible to take the square root of 1 unless you use complex numbers, but that's a whole different world, and we are not going to go there in this course. But what I want to show you is what this means. Does this mean that there is no parabola? Well, I hope we've done enough graphing to figure out that that's not true. There is a parabola here, and in fact, we're going to graph it. Okay, so I hope that this super crude drawing of a parabola goes to convince you that it doesn't mean that there is no parabola, it just means that there are no x-intercepts on your parabola. Okay, so this is connected to the fact that when I went to try to solve the equation, it was impossible. So these two things are linked. Okay, so we know that the reason there are no x-intercepts, or maybe the reason this equation is impossible to solve for x, is because there are actually no x-intercepts.